we move on to the second topic, that is PGM to power hydrogen economy. And the moderator is the Deputy Director of Anglo-American PGM Market Development, Fang. And the panelists are Mr. Zhang Bihang and from Suzhou Jingli, and Mr. Xiao Chenjiang from China Hydrogen Alliance, and Deputy GM of Green Technology Bank, Mr. Hejun, and Mr. Huang Fang from Shandong Saike, and also Mr. Hejun from Tianzhong. Welcome. Hello, everyone. I'm greatly delighted to be the moderator of the second panel discussion. Our topic is PGM to power hydrogen economy. And we are very happy to have all the specialists from this industry. One is the China Hydrogen Alliance and 4 leading companies in the industry to attend the session. I've talked to our 5 panelists before the event, and I got to know that you're very experienced industry insiders in the hydrogen industry, and you cover different parts of the industry. And today's topic is basically about the technology, business models, and international cooperation, etc. under the PGM. We'll have a 1-hour discussion based on the 4 aspects, but the previous session has taken 15 minutes of ours, so probably can quicken up a little bit. And also, I will look forward to the interactions from our audience as well. I will later on hand the mic to you, to our audience, for you to raise any questions you're interested in. We know that globally, low carbon shift is a rather good opportunity for the hydrogen industry, but also it's a big challenge as well. Although hydrogen power has been considered as an important way to achieve low carbon development and carbon neutrality, however, people are saying that we still need to work on the details. We need to work on the next directions, and we need more plans. So at the moment, for the hydrogen economy, personally, I think if we use one word, is happy pain to describe it. But I assume that a lot of you may not agree with me on that, so I'd like to listen to your opinions. So I'd like to ask one question for all of you. Please use 3 minutes, first of all, to introduce yourself, including your experience in the industry and also your opinion on the trend of hydrogen economy and your company's mission and goal in hydrogen economy. And as today's forum is about PGM, so we'd like to know that your company's relation with PGM market. So first of all, Mr. Zhang, hello. I think the moderator has touched on a few points, and I totally agree with you on that. Hydrogen is a emerging and quickly developing industry. We know that hydrogen has a gray, blue, and a green hydrogen. And today we're talking about the green hydrogen. That has points out the direction for hydrogen industry. It has a rather strong momentum. Why? Because we have the double carbon objectives. It has clearly stated that by 2030 and 2030, we have to reach carbon peaking and carbon neutrality. Under such background, we are an emerging market, a quickly expanding market. I'm from Suzhou. Jingli. I've been working for 30 years on chloride hydrogen. That is to water hydrolysis to produce hydrogen. Chloride hydrogen, what is it? It comes from renewable energy by water hydrolysis. But of course, lots of ways to approach that. But a lot of technology are still under development, among which water hydrolysis is rather mature, and it's heading towards three directions. First one is large scale. In the past, hydrolysis is rather small scale, but now it's getting larger and larger. In 2017, we have rolled out 1,000 cubic meters per hour, and now we have 1,300, 1,400, and even 2,000, 3,000. It's a very large scale. So this is a big trend. The second is energy consumption has to meet stricter requirements. Now it is required that we need to achieve better efficiency. And third, we have to conquer the instability and intermittency of the renewable energy. We need to make it more continuous and stable. And this is also touched on today's forum. And this is where we have this association with PGMs, because if without these requirements, hydrolysis, if it's alkaline electrolytes, we don't have to use precious metals. But now, as it requires higher efficiency, lower energy consumption, then we will have to resort to precious metals. That is why, with the support of Anglo-American, we are already using precious metals in our hydrolysis. We are trying it out and trying to make some innovations on that aspect. And this is a rather large market. Just a simple number, if it is 1,000 cubic meters, we will have to use 800 square meters hydrolysis or electrolyte, which means 1,600 square meters electrodes. If the electrodes contain precious metals, then it's going to be large amount of precious metals in use. So we are trying to use precious metals on the electrodes so as to improve efficiency and lower energy consumption. I think it's a very promising direction. And Frank also touched on happy pain. Well, could be, but the big trend is definitely happy and rapid. 2-3 years ago, or say 2 years ago, our industry was still very small, so only 3 to 4 big players. By last month, there are already 80 players in the field. So hydrogen growth has exceeded our imagination, and its applications will exceed our imagination as well. So the precious metal, you should look into hydrogen. Look at the hydrogen markets. I think there are going to be a lot of connecting points there and opportunities. Thank you for the invitation by Anglo-America, and also I'd like to say thank you to all the specialists here. I'm from China Hydrogen Alliance. I'm Xiao Chenjiang. I am the director of the Innovation Center of China Hydrogen Alliance. China Hydrogen Alliance was founded at the end of 2018 in cooperation with more than a dozen state-owned companies and national institutes. Now we have more than 15 members covering basically the production, storage, transportation, and application of hydrogen energy. In terms of hydrogen economy, as what has already been mentioned, is a development against the double carbon goals, low carbon, carbon peaking, and carbon neutrality. In 2030, hydrogen production will be cheaper than regenerable hydrogen, and green hydrogen will be widely used in transportation, construction, and other industries. In 2060, when it's carbon neutrality, we have made an estimate that by then the hydrogen demand will reach 130 million tons per year, among which more than 100 million will come from regenerable hydrogen, which means we need 500 gigawatts regenerable hydrogen. Against such a background, the China Hydrogen Alliance Institute aims to become the think tank for the national hydrogen economy to create a whole ecosystem that is digital and smart to support the hydrogen economy. For example, we will build a hydrogen big data platform, create and write white papers for hydrogen development and tackle different perspectives of the industry so as to provide solid support for the industry.
Thank you very much to the organizer and to the host for inviting me. I'm from China Green Bank. After the Paris Agreement was signed, President Xi Jinping made his statement at UN General Assembly and saying that China have to export our green technology. We need to have a China Green Technology Library or bank. So after several rounds of discussions, the Chinese Ministry of Technology and Science led the effort to build this bank, and the ministry said that we need to do something to explore a sound model, and we wanted to cooperate with the Shanghai municipal government to join to launch this organization, but later we were asked not to become NGO, nor could we be a subsidiary or office under any government departments. That's why we become a commercial entity. But our goal is to use financial market, use it as leverage to facilitate the development of the hydrogen industry and economy. That's the background of the establishment of China Green Bank. So this time I was invited by Anglo America to attend this panel discussion, probably because we got some invitation from Maersk to produce green methanol. Personally, I have been in the energy industry for nearly 3 decades, so I'm a seasoned industry participant. My first job was with Sinopec, and my first job was about hydrogen refueling, PSA, hydrogen production. I was in that business for 12 years. All the production facilities I was responsible for managing and O&M of these facilities. So back then, we used precious metal catalysts. I had lots of feelings about this because less than 1 cubic meter, 1 million RMB was invested as it all contained precious metal. So today I'm really honored to have this chance to participate in the panel discussion. It brings back memories of me working at Sinopec and back to hydrogen. Hydrogen for the petrochemical industry is very important and very good fuel. In fact, it's for a lot of industry. Hydrogen acts as a reduction agent. In particular, in petrochemical, addition of hydrogen becomes increasingly larger, and use of precious metal is also surprising. So hydrogen turns from fuel turns from reagent from reduction agent to fuel, starting with President Xi Jinping's statements. And later on, people are increasingly interested in how to use hydrogen as a fuel. So today, at the invitation of Anglo America, I'm going to talk about the revolution in the fuel industry, in particular with regard to shipping fuel. As mentioned, the purpose of our bank is to act as a semi-governmental, non-governmental organization. We want to be a bridge between the government and the industry. So as we were invited by Maersk, we managed to push forward this project. And I'm really happy to have the chance to share with you some of the latest updates from that project. Good afternoon. Thank you very much to Anglo America, in particular to Frank for the invitation. I'm from Shandong Success Hydrogen Energy Company. In fact, it's fair to say that we have had a long history of engagement with Anglo America because we did pure water electrolysis. So we have huge amounts for PGM. Currently, from the previous round of panel discussion, I had the feeling that maybe in the area of platinum and PGM, regarding recycling, production, and development, everything means lots to lots. And in the meantime, if you know anything about water electrolyzers, you may know that in the current field of hydrogen production using or in the area of fuel cell, PAM catalyst determines the lion's share of the overall cost because it accounts for around 40% of the total cost. So our next step is to think about something to bring the cost down. We will do something to lower the costs. And for us, we will mainly focus on cost-saving space from the catalyst. So for us, together with Anglo America and relevant industry stakeholders, we do hope that we can do some technical upgrading to bring down the loading of PGM and to find substitution for PGM. That's what we will be doing going forward. A few words about my company. My company success hydrogen energy starts with PEM, pure water electrolyzers as early as 2007. A difference from what the Mr. Zhang Bihang's company is doing as they have other technological pathway. Water electrolysis is a niche market and PEM water electrolysis is niche of the niche. But our company has been running for 15 years. Well, that's not a small achievement. But because China tries to attain carbon strategy and carbon peak, we have more breathing space. For our equipment, so we can do 1 megawatt or 200 standard cubic meter size for single unit. And we try to, at the end of 2025, launch 5 megawatts tonnage, 5 megawatt scale for a single unit. That will contribute to China's hydrogen economy development because PAM has advantages in that it can be coupled with renewable energy. People talk about carbon trust and carbon peak as we try to do energy transition and we try to find more possible alternative energies and we try to make our due contribution in this field regarding renewable energy, regarding energy storage, regarding the modulation of the grid, and regarding the production and storage as well as transportation of hydrogen. I want to make our due share in all of these areas. I'd like to share with you some figure. According to our calculation, by 2030, PAM market will reach around 250 billion RMB. So if that's the case, what we need to do is for 1 cubic meter of product, the cost will be around 30,000 RMB. So according to additional testing, total stock capacity of PAM will reach 40 megawatts, gigawatt or something. So last year we did some additional calculation about the annual output of precious matter. Back then, we calculated enough output for installed capacity of around 20 gigawatts. So from this perspective, the requirement for precious matter or for PGM in general is that there is a gap. What we need to do is we will lower down the loadings of PGM. For example, we can lower to 5 to 10% on the cathode. For anode, we use iridium catalyst. We bring it down to between 70% to 80%. With that, we manage to better tackle or deal with the situation concerning precious metals insufficient supply. We're also working with universities and research institutes to develop catalysts not using precious metal in order to alleviate the situation of insufficient supply of precious metal. So on the whole, under the current supply chain from our customers to us all the way to our upstream suppliers, the suppliers of precious metal and in particular PGM, we do see consistency in all of the stakeholders in the value chain. So I do hope that people along the value chain can work together to make the system better, to build a better ecosystem so that we have a more science-based way to develop hydrogen better and bring the costs down even more. Thank you. I'm from Tianzhong, Precious Metals Shanghai. My name is Liu Hejun. As Shanghai for our company is very important as our China's subsidiaries are located in Shanghai. So Tianzhong is a hydrogen company. As you know, that the world hydrogen economy was first proposed by Japan. And in the precious metal industry, my company in the fields of precious metal and in particular in PGM has a lot of products and technologies. Because I'm in this field myself, so I do want to share with you in what areas and in what products precious metals will be used and what kind of precious metals are used in fuel cell. We usually use platinum carbon catalysts in the production of hydrogen. There are various pathways, including SMR. SMR process uses RU-based catalysts, and for red formation catalysts, we also use iridium, ruthenium catalysts. But if it's pure water electrolyzers, platinum and iridium oxide catalysts are used. There is another type of platinum called PGM called palladium. Palladium is used in the process of purification of hydrogen. So palladium membrane or palladium tube might be used in order to do the purification of hydrogen. Tanaka, my company, started with the R&D of fuel cell catalysts as early as 1980s, and our factory is located in Japan. And so currently our monthly output is around 700 kilograms of fuel cell catalysts. So as people around the world are developing hydrogen, are working on technical innovations regarding hydrogen, we are making our due contribution as well. So much from me. Thank you very much to all the panelists for sharing with us the situation with their company they represent and with the goals that their companies are pursuing. So for the second round of discussions, actually something we're going to talk about something that you already covered during the first round. Here I want to quote from the most recent goal issued by China Hydrogen Alliance that by 2030 we want to reach 100 gigawatts at the conservative scale, because I have seen more aggressive numbers, but people can have different opinions on this front. I do think that currently single digit or less than or just several gigawatts of the market is the reality. We are almost approaching the end of 2022. It means that we only have 8 years to go. However, we need to go from several gigawatts to 100 gigawatts, and that's only for renewable hydrogen or green hydrogen, as was mentioned by Mr. Zhang. For PGM has applications in the production, storage, and application of hydrogen. PGM plays a very important role in all of these areas, playing an indispensable role, fairly speaking. So how can we work together with renowned companies in order to better attain the goal regarding green hydrogen as was proposed by China Hydrogen Alliance? So I'd like to hear from your insights what key technical innovations that you think we need and what are the challenges when it comes to commercialization and further promotion. Mr. Zhang, as I mentioned that the market has totally changed, which is similar to platinum. Platinum market has changed as well. I think that hydrogen not only needs to say that it's fair to say that it's going to be a very important market because the market is just too large. As someone from the lines puts it very aptly, that going forward, 800 billion RMB market in 10 years. In other words, every year, 80 billion RMB. What is the status quo? The status quo is that market is only worth 800 million. Our company generated 250 million last year, and our goal is to reach 500 million this year. If we can achieve this goal, that means that we can contribute less than 50% of the industry, and currently we've already achieved 300 megawatts production. And at the end of this year, there will be a number published, and this year we'll expect to reach 600 megawatts at the end of this year. For the markets, the way forward is for us to rely upon precious metal. We need to rely upon precious metal. Mr. Huang from Texas Hejun Energy said that PEM is used extensively in great quantity, so they are working on bringing the loading of PGM down. But we work on alkaline electrolyzers. For alkaline electrolyzers, 90% of green hydrogen production will be contributed by alkaline electrolyzers process, because the price of green hydrogen generated in this way is much lower than any other alternatives. So for this market, currently the market is facing the conundrum of bringing down the costs, whereas increasing the efficiency. In the meantime, we need to bring down the energy consumption. But what is the energy consumption currently? For 1 cubic meter of hydrogen, 4.5 kilowatt hours of electricity is consumed. According to some goals proposed by companies and institutions, we must bring the energy consumption down by 10 to 15% in the next 2 to 3 years at minimum, because the big users of energy, they have this requirement. They request us to do it, because only by bringing down energy consumption in producing green hydrogen will green hydrogen production truly contribute its due share to the carbon neutrality future. So in terms of R&D and from the perspective of actual usage, the use of precious matter to increase the electrolytic activity and the efficiency of electrolysis represents the most effective methodology or pathway. So going forward, hydrogen will represent major market dominant, whereas the emerging market for PGM demand, but we still think there are things to be done. As Professor Li from Zhejiang Polytech University aptly put it, and I got a lot of inspiration from her statement. As people working in the electrodes industry, we use precious metal as catalysts as well. However, such catalysts, if you take a look at the overall cycle of production, there are various problems that we're currently facing, including its endurance and the attack or the impact of reverse electric current. All these require continuous and constant innovations on the technology fronts. So we're working with Suzhou University, Liangzhou University, and Changzhou University on some key technical projects in order to have technical breakthroughs on all this front. But one thing is for sure, after using precious metal, efficiency will definitely go up. The yield per unit will definitely go up, and the energy consumption will obviously go down. That's for sure. But the market is too large. Precious metal, I do think there are lots of issues, lots of uncertainties there. Of course, I've learned a lot from these discussions today. I do think that recycling is a very important part of the puzzle. Hydrogen produced using water electrolyzers has at least 10 years of life. If, say, at the end of the 10 years, if at the end of life you can recycle the precious metals, that will help bring the cost down and also contribute to the sustainable utilization of resources, like perpetually. So from the perspective of alkaline electrolyzers, During the luncheon party, we heard from Mr. Chen, from Tony Chen. I joke with him that you need to pay attention to alkaline electrolyzers as well. PEM is of course important, but alkaline is just too large to be ignored. At the end of this year, or by the end of this year, production by alkaline process will reach or exceed 10 gigawatts. What does that mean? It means 1,000 cubic meters of electrolyzers per year. You need 2,000 such electrolyzers of that mega scale. One electrolyzer weighs around 46 tons. That's already tremendous. So for 10 gigawatts, 10 gigawatts only represent the goal by the end of this year. Maybe the number will double next year and quadruple the year after next year. So the demand is just huge. If we look at the number, 80 billion represents some sort of multiplier effect at the exponential scale. So I do think that people in the precious metal industry can fully understand that this represents some sort of hugely promising market in the future. But for us, we do hope extensive application, but in the most optimal way.
And we are hoping that we can roll it in large scale. This is what we are hoping to see. I think this is an extension to the first question. Actually, Mr. Zhang proposed one important topic, that is we need to keep a key attention on the PGM market to see how it can facilitate the alkaline electrolyte hydrogen production industry, as alkaline electrolytes still take a dominant part of the market. It has a huge output. So this year we've already had 10 companies who launched this at 1,000, 1,200, 1,300 cubic meters electrolyzers. So of course, that deserves our close attention. Now I'd like to listen to China Hydrogen Alliance, what they have done to activate the market, to make everyone collaborate and work together. Well, thank you. I totally agree with Mr. Zhang, be it in China or overseas, Europe, America, or Japan. Hydrolysis for hydrogen production is a dominant approach. People agree on that. And for green hydrogen, be it the Paris Agreement or carbon neutrality, is an important way out, and it relies on the PGMs. If we move further down the road, it look at the electrolyzers. Now we mostly look at alkaline hydrolysis as scale up and PEM. And I can see that we are mostly focused on the efficiency of hydrogen production and on the improvement of durability, reliability, and reduce cost, improve efficiency. This is the direction we're working on. But at the same time, after decades of development in renewable energy, since 2001, the solar energy and wind energy's pricing is getting closer to power plant generated energy, and be it PEM or alkaline hydrolysis electrolyzers, we still have further room to reduce our prices. Plus, the renewable energy's prices is going down as well. So in the near future, properly renewable hydrogen production will become a dominant or say mainstream technology. And in industry, we also detected some challenges. First is that the whole industry still do not have standardized standards concerning the electrolytes, and most enterprises has proposed their own standards, but it's not unified. And the market at the moment doesn't have a uniform starting line or say testing platform. Then for big players and end users in China, when they enter this industry, when they roll out pilot projects in hydrogen production, they don't really understand that much about the cost and the efficiency of these electrolyzers, and they will have promotion costs. And all these will become the barriers on the road for the scaling up of the electrolyzers. So China Hydrogen Alliance, under the support of the Chinese Association of Science Technology, we are rolling out a leading runners project to set up a unified standards, testing platform, and entrance accreditation organizations. So far, we have completed the phase 1 product accreditation for the electrolyzers, including the products by Mr. Zhang's company. And in the coming months, with the expert committee's accreditation, we will provide a wide list. And by doing that, we're hoping that we can set up standards and quality improvement plans for the whole industry, so people can move faster in this industry in terms of hydrogen production. So here I'd like to share 3 points of views of mine. I have a technical background, and later on I was a technically oriented sales person. When we talk about training, we say that we need to be customer-oriented. We need to start from the customers. However, in practice, we tend to start from our own source. But now I'm working on the platform company. We don't have much strong technical background. Therefore, our opinion is that we go back to the starting point, the customer's needs. If we look at the shipping industry and its fuel demand, in the past few years, we noticed that a lot of hydrogen are being used in transportation, for example, for heavy-duty trucks and sharing vehicles, and even hydrogen-powered scooters. I see that in the north part of China and the southwest part of China, there are people working on quickly charging hydrogen stored tanks to support these scooters. But my first reflection is that it has a logic behind it. That is IMO. For all of you here, if you're not in the shipping industry, you won't notice the IMO's 2050 strategy. That is to reduce carbon by 50% by 2020. Then they have several stages, 2020, 2030, and 2050. Then all the shipping industry is faced with a great pressure to lower their carbon. So they need to find renewable energy as a replacement. But at the same time, the shipping industry, land transportation, and the aviation industry, they cover 3 ways of transportation, and they have different requirements concerning the pressure and the density of these energies. And for the shipping industry, they need this. It's more adapted to renewable energy, but for aviation, it's less adaptable. Some people in the aviation industry has asked me about it, and I told them that you can only think about biofuel because they can't tolerate a 10, 20, or 30% reduction in their density. And the European Union has stated that biomaterials, biofuel, is a very important way out for the aviation industry. And of course, that is closely associated with the PGMs, and it is a low-density energy or fuel, and normal temperature and pressure. So for the shipping industry, they can't say stop every couple of hours to be filled with be it diesel, gasoline, or hydrogen. And that's going to create extra costs, and it's simply not possible. So for the shipping industry, so this solution proposed by Ji is not it's based on massive research and industry experience. And after he announced his strategy, a lot of followers come up in the industry to order ships powered by methyl alcohol. So that means I took this case just to tell you that we need to look at the customers, at their needs. Say for the shipping industry, for the aviation industry, and land transportation, they have different requirements. For land transportation, they can stop at fuel stations to be filled or charged. So it is more flexible in terms of fuel density and mileage range. So for us as producers and manufacturers, we really need to go back to the customers' need to analyze it, to imagine the scenarios for application. The second point of mine is the energy structure decides the application structure. All the momentum comes from pricing, right? So we've touched on that in a previous session, that the platinum was really cheap, 100 to 200 per unit, but now it's 1,000 to 2,000. Then all the market started to grow, so meaning the whole market is price-driven. Another example is about film recycling. In the 1970s, iron and steel was really expensive, while crude oil was so cheap. Then by 2008, the situation has greatly changed, meaning that people will start to collect the residue heat. So the market is price-driven, and also the energy structure is price-driven. We need to produce value-added and highly tolerant and highly efficient products for our customers. I think that most of you won't really know much about methyl alcohol, but as working on this platform, I've been keeping a close eye on that. And last year, it sold 6,000 tons of methyl alcohol. And I talked to an industry insider that how about we cooperate on green methyl alcohol? And he said, no, definitely not. It's so competitive. And I'm thinking about leaving this field. Then I just got it. Then we talked about look at this green market. So for methyl alcohol is about 2,000 to 3,000 per ton, and for green methyl alcohol in Europe is about 10,000. In China, it can easily go up to more than 5,000. Then with this price over there, people will feel more motivated to dive into the industry. So my point is, the first thing is the customer's demand. The second is pricing, or say price. And we all know that all this development is also partly influenced by the policymakers. For example, the EU's new environmental pact. So from heavy oil to diesel to methyl alcohol to green methyl alcohol, etc., of course, is part of the macro policies changes. And also, I would like to say it is driven by the price.
And third, I will talk about ecosystem or alliance partnership, because we talk about infrastructure, binding it with financial system. In other words, we call ourselves a technological company with financial connections, or we call ourselves a financial institution with technological prowess, or connoisseur. So what we want to do is we want to put in place a green partnership plan. We want to work with relevant stakeholders to form consensus to meet the needs of customers. Of course, the client or the customer must be large enough so that we design something customized for them. So today, the panel discussion hosted by Anglo American, I think, is for the purpose of putting in place such an ecosystem. So I I do think that whether you have resources or you have needs, let's just put them together so that we can achieve something bigger. Thank you very much. I just want to add one more thing. Many thanks to you for your insights, for analysis, and for your exploratory business model with regard to green methanol, because I have some data I want to share you. This data is taken from Anglo-American internally. About a year ago, we already proposed the idea that by 2040, at the group level, we needed to achieve carbon neutrality. And in November 2020, at the group level, at the marketing center of our group, we had a fleet because we had commodities including iron ore from Brazil, copper from South America, nickel also from South America, coke from Australia. So we have a shipping department, and they work day in, day out in the shipping business, in the shipping industry doing some business. So in November 2001, we leased 4 LNG-powered vessels. That has made important environmental sense because with that action, we managed to bring down CO2 emissions by 35% as one goal. And also it addresses what you just mentioned, the emissions of incomplete burning of methanol. We hope that we can continue to push forward on this front, and I hope that for the shipping industry, for the ocean-going shipping industry, we can build some thing of reference value. You mentioned that you want to become a technology company with investment capabilities or investment company with technological connoisseur. I am confident that with your capabilities, with your skill set, you will be well received in China as well as internationally. Thank you very much. Our next speaker is Mr. Huang. I'd like to say a few words about hydrogen, because hydrogen, well, based on renewable energy, but hydrogen is developed on top of that. It represents some secondary energy source. So we, on this basis, proposed a carbon neutrality and carbon peak goals according to some experts. If we were to achieve carbon neutrality by 2030, China's nuclear power installed capacity must be 5 times the current level and 12 times regarding wind, and 70 times compared with existing PV installed capacity. That means when that becomes reality, there will be excess power, and hydrogen can be combined with this renewable energy for energy storage in order for us to better achieve decarbonization. According to International Hydrogen Energy Council, hydrogen has several roles. As was mentioned by some previous speakers, hydrogen can be used for the decarbonization of transportation, industrial processes, construction of buildings, and can serve as elastic buffer of energy. So that's the overall function of hydrogen. As a result, we did this 100 gigawatts installed capacity of hydrogen production facility. This is a goal that's not beyond impossible because some local governments already launched such documents about energy storage facilities for renewable energy, say at 20 or 30%. And this is also there for, this hydrogen also represents a reasonable way of storing energy, in particular renewable energy that represents huge space for the growth of hydrogen. One more thing I want to mention is that there are several interesting phenomena in the field of hydrogen. Mr. Zhang, a previous speaker, mentioned or touched upon the cost. Another thing is that alkaline process keeps increasing the use of catalyst as opposed to PAM, we keep decreasing the use of catalyst because alkaline water has to improve the efficiency of electrolysis, whereas for PAM process, our center focus is to bring the costs down. So that's the first interesting phenomenon. Second, China is actively and is putting a lot of force in developing alkaline water electrolyzers. For example, 1,200, 1,300 stands cubic meter facilities. They have been added to the mix in Europe and the United States. PAM is all the rage nowadays, including some projects in the United States announcing that they would focus on PAM and they would put aside alkaline electrolyzers. There is an alkaline electrolyzers company purchasing some American company that focuses on PAM. So in the future, with regard to the development of green hydrogen, that provides some sort of bellwether effect. Well, for us in the PAM business, as was mentioned by some previous speaker, PAM's cost is relatively high. However, what I want to say is that we started as early as 2007 and we survived until today. We have been trying to explore new scenarios for PAM. We have managed to do well. For example, last year we managed to double our size compared with the year before. And our goal for this year is that we will be twice larger compared with last year. All this attests to the fact that PAM is still a promising process, and we see lots more players join the game. It's just that PAM is more difficult, has higher threshold, and for PAM's investment recoup cycle, it will be longer. But that's not necessarily a bad thing because what we mostly concerned with is what was proposed by President Xi Jinping about China to achieve carbon neutrality and carbon peak, and people quickly acted upon that 1 and 2 years later after his statement. So what I see from this is that people first of all try to figure out the fields, and then they try to figure out what their role will be in the field. So I'm still confident about PAM because PAM is based on renewable energy. It has this advantage of having good coupling effect with renewable energy. We can achieve 150%, whereas in lab we can achieve modulation range between 0% to 300%, which makes it a perfect partner for accommodating the intermittence of renewable energy. As for cold start, microseconds level, and hot start, microseconds level, and thirdly, no emissions because it's pure water based. That's another direction that we are aiming for going forward, mainly based on the fact that PAM's medium doesn't have any polluting chemicals, which is different from alkaline process or the dissolution of ammonia, as the latter processes uses chemical compounds and chemicals. So the integrated hydrogen production and refueling station that we're working on will make hydrogen refueling much more convenient, and it can greatly reduce the security concerns in the O&M process because we did some calculation for some city for them to have 1,000 buses to run on the road. The tank needed on a daily basis could reach 300 vehicles. So that causes additional security concerns. With all these, I do think that for PAM, there's still room for it to increase its market proportion or market share. According to some international calculation, by 2030, 60-40% respectively when it comes to how alkaline compare with PAM, 60-40%. Together with our suppliers, including Anglo America and our downstream clients, we're working on how to better bring down the costs. And our goal is that by 2030, $1,000 per kilowatts. That's our goal for 2030. So we still see a lot of room for lowering down the costs, mainly because in the previous phase, the market is so small. All the components, all the filling materials, materials or the raw materials, they come in customized formats. In other words, the cost is 10 times higher than non-customized products. However, as we are in this stage, some people working in colors, some people working in carbon, some people working in sealing materials. As a result, for all of our components, we have at least 4 to 5 suppliers for each and every one piece, or each and every one type of component, which is something that beyond our wide stream in the past. As a result, we can bring the PAM cost down. Maybe similar to fuel cells cost a couple of years ago, fuel cells cost was between 10 to 20K, but this year I listened to some quotation as low as 9,999 for fuel cell. What's more, we also see the further evolution of the recycling of precious metal business that will also be conducive to bringing down the cost of PAM and water electrolyzers in general. I also discussed with Mr. Li whether there are other ways of getting PAM and bringing down the cost, whether there are ways for us to form a new ecosystem. So I think for us on the whole, what we think is that
the further cost reduction in hydrogen production, if it can be further lowered to less than 30 RMB per ton, then it's going to be better. It means lower cost for the equipment and for hydrolysis, etc. Because and also they reduce of electricity consumption, because 70% of hydrogen production's cost goes to electricity and power consumption. So if we can further lower it to a certain extent, then the green hydrogen compared with traditional blue and gray hydrogen will have more advantages, and also compared with traditional fossil fuels like gasoline and diesel, it will have more advantages as well. By then, hydrogen will have a exponential growth. Hello, Mr. Liu. I've been listening to all the specialists talking about lowering costs. I work on catalyst, and people say catalyst is the most expensive. That is because it comes precious metals. Our company's cost is mostly precious metals plus processing, and we only charge for processing. If we look at the fuel cells, the industry has been developing really fast, and the platinum titanium processing cost has been going down, so it's getting cheaper, and also the recycling rate is going up, so the platinum catalyst price is going down, and with a large scale of processing, the processing fee is going down as well. According to our statistics, some of our big clients asked us to quote for 30 to 50 kilograms. Then they found that we are even cheaper than some domestic products. Why is that? Because from precious metal composite, its production, its recycling, is a whole solution that covers it all. So during the process, we can efficiently lower the cost. You mentioned the 999 for 1 kilowatts. Yes, the cost is going down. If we exclude the cost for precious metals, then the process actually is getting cheaper and cheaper. Our profit margin as a catalyst manufacturer is quite narrow. And for hydrogen production, we use a lot of iridium. For platinum, we have over-sufficient supply, but of course, in the future, it may become insufficient. But for iridium, we do not have much reserves global-wise, and if we don't recycle it, the cost will go up. So the cost of iridium in hydrolysis is an uncertain factor. How expensive will it get? This is the part that is difficult to control when we want to lower the cost. So when we are trying to lower the cost, so we need to look like recycling and the market size. If we use iridium as a stack, as a kind of asset for the hydrolysis, and we only charge for the processing. Will that be possible for a way ahead? As iridium is a catalyst, it stays there anyway. Thank you for your sharing. I promised you that we will have a question for the audience, but due to the time limit, we will have only one question from our audience. So please raise your hand. Hello, panelists. I'm an analyst in precious metals. You've touched on that question. Thank you for that question. PAM's advantage is that its power fluctuation and its quick response. Against this background, when we do PAM hydrolysis, we want to have it better coupled with other technologies, and when the PAM system is relatively simple, the raw material is just water. So it can have more advantages if we use it for those fueling stations. We will still focus on the storage of the green hydrogen, and that is a key focus, or say the point for the breakthrough for us. In China, we have a vast lands and we have very abundant natural resources. And in such circumstances, alkaline hydrolysis is also a key approach for hydrogen production. It can be complementary to PAM. And now we call alkaline hydrolysis and hydrolysis both as just hydrolysis. It takes about 10%. And for pure water hydrolysis, it takes only 1% at the moment. And by 2020, we are hoping to expand the market to 250 billion. Then the capacity will be further expanded to 40 gigawatts. As more listed companies and state-owned companies enter this industry, we think China's green hydrogen industry and China's carbon peak and carbon neutrality goals will move forward as expected. On August 27th, on the New Energy Vehicles Forum, they said that China is a hot land for the development of new energy, including green hydrogen. If it can take root in China, then it will definitely be able to be promoted to the rest of the world. So it's a very promising area, and we still have a lot of homework to do. If you have watched the video we played at the start of today's event, last year we had a workshop on hydrolysis for hydrogen production, and I had two takeaways from that session. One is from Professor Huang from Dalian Institute of Chemical Physics. He pointed out that be it PAM or other technology, its catalyst technology is still the same to that of the 5 years or 10 years ago, and it is still true today. And if I ask Professor Chulina from Shanghai Jiaotong University to talk about it, actually she's touched on that last week. She's talked about it from a more global perspective and pointed out some new directions and new ways of thinking. We're talking about 100 gigawatts. It's just China. If China can take 20-50%, then you can calculate that the global capacity will be 50 or even more than that. So is PAM better or is alkaline better? I think for this field, we still have a lot of opportunities. We need to seize the opportunities. Due to the time limit, I want to have 1 minute for our panelists to give a good wish to today's topic, that is PGM to power hydrogen economy. Just one sentence, that is green electricity plus green hydrogen to reach 1.5 RMB per cubic meter of hydrogen is possible with the support of precious metals markets. For renewable hydrogen's prospects, we are a little bit radical. We hope that PGM's role in the value chain can be bigger. It can play a larger role for the commercialization and the scaling up of the hydrogen economy. I hope that PGM market can help China to achieve its carbon peaking and carbon neutrality as soon as possible. And I want to say that I hope that I can take this opportunity to meet with more friends, and we can all take part in this low carbon journey. Thank you, Frank. Thank you, Anglo-American. Hydrogen's development is still at its starting phase, and we have this seminar here to talk about PGM. I think we do have a very forward-looking mindset, and we didn't really think much about how to recycle it, how to use it. But now PGM's price has increased by 3 or 4 folds. Oh, that's just iridium. So people are paying more attention. So I think today's discussion has provided a very good way of thinking that is renewable, regenerative, and recycling. I think this is a very important. So thank you for providing this opportunity for this kind of dialogue. I want to say that in the hydrogen industry, China is not the first one to start, but China is the one that's developed the quickest. So I think, and also China is one of the largest markets. So for PGM, platinum, palladium, osmium, iridium, ruthenium, rhodium, we can all work together to contribute to the low carbon development of China. Okay, thank you, all the panelists. One last sentence for international cooperation, global innovation, and economy of scale. We hope that with support of China Hydrogen Alliance and all the industry leaders, we can pull together all the efforts to further optimize the hydrogen value chain to pooling hydrogen-powered shipping, transportation, aviation, construction, infrastructure, etc., to dig into all the demands for hydrogen energy to further quicken our steps on this journey. So this is the end of this panel discussion. Thank you.